Hello and welcome to our sixth video in the Year 9 Surds series. Today we'll be talking about the multiplication of surds. So to start off this video, we want to go through a quick rundown of the different algebraic terms and how we can expand and simplify. So looking at our first example, we have x plus y all squared. Now it's really important to remember either the formula or just remember how to do this by using the long expansion. So let's first do the long expansion and then we can derive the formula. So x plus y all squared is basically the same as saying x plus y times x plus y, because remember when we square something, it just means multiplying something by itself twice. And now we've got this, we can actually expand it out. So remember, with all of these kind of questions, we want to be getting every single combination and then just work from there. So we have x times x, which gives us x squared. We have x times y, so that's going to be plus xy. Then we have y times x, which is yx, but that's the same as saying xy again. And then we have y times y, which is going to be plus y squared. So now we can collect any like terms, and hopefully you can see that xy over here and the xy over here are both like terms. So one xy plus another xy is just going to give us 2xy. So this simplifies to be x squared plus 2xy plus y squared. Most textbooks like to leave it like this, but I personally like to write it as x squared plus y squared plus 2xy. That's just a personal preference, and I'll talk about that later in questions 3 and 4. Now, the way we're going to think about this is if we have something plus something all squared, it just means it's equal to the first thing squared plus the second thing squared plus twice the first thing times the second thing. So if you can keep that mantra in your mind while we do these questions, it's going to really pay off. Now let's have a go at question 2. So question 2, we have x plus y times x minus y. Now, hopefully you can remember this is actually just the difference of squares formula, and it's just going to equal x squared minus y squared. But for those of you who are unfamiliar with this, let's just quickly expand it out the long way. So once again, we want every combination possible. So we have x times x, which gives us x squared. Then we have x times minus y, which is minus xy. Then we have y times x, which is just plus yx or plus xy. And then we have y times minus y, which is going to be minus y squared. So now we can hopefully see that there's a bit of cancellation happening because we have the minus xy and the plus xy. So they will cancel out, leaving us with just x squared minus y squared. So really the formula is that x plus y times x minus y is equal to first thing squared minus the second thing squared. And it's important that you can see it vice versa, right? So when you have a square thing minus another square thing, realize that we can factorize it as difference of squares. So now let's move on to example 3. 2a minus 3b all squared. So remember, I want you to think about what we did in part 1. We have something, in this case, it's a minus. So in fact, I'll quickly show you the formula for x minus y all squared. It's going to be very similar. It's just going to be x squared plus y squared minus 2xy. And we can prove that just like we proved question 1, but I'm not going to go into that in this video. It should all be revision at this point. So with question 3, we can see we have something minus another something all squared. So looking at this formula, we can see it's the first thing squared. So we square the 2a, and I like to use brackets because we're squaring everything, yeah? A lot of students will just say it's 2a squared, but in reality, it's going to be 4a squared because we have to square the 2 and square the a. Next, we have our second thing squared. So it's plus our second thing squared. Now, our second thing is 3b. So 3b all squared, and then minus twice, so 2 times the first thing times the second thing. So this is what this is going to equal. Now, as I said, 2a all squared is just going to be 4a squared. plus 3b all squared is just going to be 3b times 3b, which is 9b squared. And then if we just collect all the numbers here, so 2 times 2 times 3 is going to give us 12. And then we have a times b, so it's just 12ab. And this is going to be our final answer for question 3. And finally, if we look at question 4, this is very similar to question 2, except instead of an x, we have a 9y, and instead of a y, we have a 4x. So it's really just something minus something times something plus something. We should be thinking difference of squares, and that means we want to be looking at the first thing all squared minus the second thing all squared. So 9y all squared, remember we just square both bits, so square the 9 we get 81, square the y we get y squared, and then minus square the 4 we get 16, square the x we get x squared. And so this is going to be our answer for question 4. And it's so much better to just use difference of squares straight away rather than expanding out every single combination, which is going to be 4 terms, and then we have to simplify. So hopefully that makes sense. So now moving on to the topic of expanding surds. So when dealing with surds, we simply follow the same idea as what we did previously, right? So it's really important to understand that when we're squaring a square root, it just becomes the number inside. And really, we need to also remember our surd laws. So root x times root y is equal to root xy. We should remember that. And we should also remember that root x divided by root y is equal to root x over y. Although this second law isn't too important for these questions that we're going to be doing now. So let's have a go at question 1. With question 1, what do we have to do? We have to look at the question and it's like, okay, we have a something all squared. Now this should jog your memory to the formula we did just previously. It's x plus y all squared is equal to x squared plus y squared plus 2xy. But in this case, our x is a root 5 and our y is a root 2. So let's just plug it into the formula. So we have root 5 all squared plus root 2 all squared, and then plus 2 times root 5 times root 2, right? So I've just plugged it into this formula over here. So that means we're going to get root 5 squared, which is 5, plus root 2 squared, which is 2, and then we have plus 2 times, now, this is where this third law comes into play. Root 5 times root 2 is equal to root 10, so we're going to end up with 2 root 10, and now 5 plus 2 equals 7, so we can collect some like terms and say 7 plus 2 root 10. So that would be our final answer. So now moving on to question 2, we have a very similar question, except this time we should probably be using x minus y all squared. And remember the formula for that is just x squared plus y squared, except here the sign is a minus, so it's going to be minus 2 times xy. So let's have a go. So we're going to be squaring the first term, which is 3 root 2. Then we're going to be adding on the square of the second term, which is 2 root 3. And then we're going to be minusing 2 times the first term times the second term. Now, let's have a go at simplifying this. This one's a bit tricky, but remember, we just need to square each thing individually. So if we're squaring the 3, we get a 9. And if we're squaring the root 2, we just get whatever's inside, which is 2. So we have 9 and 2. 9 times 2 is 18. So remember, 3 root 2 all squared is going to be 18. And that makes sense because if we remember from our simplifying surds video, 3 root 2 is actually equal to root 18. And so we can say the square is just 18. Similarly, when we square 2 root 3, it's just going to be square of 2, which is 4, square of root 3, which is 3. So 4 times 3 is 12. And now minus, here we have 2 times 3 times 2. So that's going to equal 12. And then we have root 2 times root 3, which is root 6. And now we can say, well, 18 plus 12 is just 30. and 30 minus, we have 12 root 6. So this would be our final answer for question 2. So now let's move on to question 3. So for question 3, hopefully you can see this is a difference of squares question. We have an x minus y times an x plus y, and that should just equal x squared minus y squared. In this case, you can see that x is 2 root 7, and the y is going to be 6 root 3. So really, we can go straight to the formula and say it's going to be equal to 2 root 7 all squared minus 6 root 3 all squared. Now 2 root 7 all squared, well, we square the 2, which gives us 4, square the root 7, which gives us 7. So 4 times 7 is 28, and then minus square the 6, which is 36, square the root 3, which is 3. So we get 36 times 3, which is equal to 108. So we get 28 minus 108, which is negative 90. And that is our answer for question 3. So now we have a set of easy examples. So pause the video here and have a go at all 4, and then unpause so that we can go through the solutions. Okay, so for question 1, we're just going to be using the formulas. In fact, it might be a good idea to list all of our formulas down right now, because I can see that looking through these questions, we'll be using all of them. So x plus y all squared is, remember, x squared plus y squared plus 2xy. Remember that x minus y all squared is equal to x squared plus y squared minus 2xy. And then x minus y times x plus y is equal to x squared minus y squared. So looking at question 1 now, we can see we're going to be using our second formula here. So we square the 2 root 5, so 2 root 5 all squared, plus 3 root 10 all squared, minus 2 times the 2 root 5, and then times it by the 3 root 10. Now, 2 root 5 all squared, we square the 2 gives us 4, square the root 5 gives us 5, so that gives us 4 times 5, which is 20. Then we have square the 3, which is 9, square the root 10, which is 10. So 9 times 10 is 90. Now here we have 2 times 2 times 3, which is 12, so minus 12. And then we have root 5 times root 10, which is root 50. Now it's important that with the previous questions, we didn't actually have to simplify any of the surds because they were already super simplified. But here we can simplify the root 50, right? So let's just quickly run through these. 20 plus 90 is 110. Now, root 50 we can write as 5 root 2. Now, if you don't know how that works, please refer to the simplifying surds video. But for now, we're just going to go straight into simplifying surds without doing all the working out because it should be expected by now. So we've got 110 minus 12 times 5 root 2, which just simplifies to, well, 12 times 5 is 60, so minus 60 root 2, and that is our final answer for question 1. So for question 2, we're going to be using the first formula, so it's really just much of the same, 2 root 3 all squared plus 3 root 5 all squared minus, plus, because it's a plus here, 2 times 2 root 3 times 3 times root 5. So now we're going to simplify. Square of 2 is 4. Square of root 3 is 3. So that just gives us 4 times 3, which is 12. Plus, we have square of 3, which is 9. Square of root 5, which is 5. 9 times 5 is 45. Then we have plus 2 times 2 times 3, which is going to give us 12. And then root 3 times root 5, which is root 15. Thankfully, we can't actually simplify root 15 anymore. So we just go from 12 plus 45, which is 57, and say our final answer is 57 plus 12 root 15. For question 3, we're going to be using our second formula again. So I'm just going to write it out real quick. We have 5 root 14 squared plus 3 root 21 squared minus 2 times 5 root 14 times 3 root 21. Now these numbers are getting a bit annoying, but still same process. 5 squared is 25, 25, and then we have square of root 14, which is 14. So 25 times 14 is equal to 350. Then we have the square of 3, which is 9, and the square of root 21, which is 21. So we have 21 times 9, which is 189. Then we have 2 times 5 times 3, which is equal to 30. And then we have root 14 times root 21, which is just root 294. Now, 350 plus 189 is equal to 539. And then we can simplify root 294 into 7 root 6. So then we can say 539 minus 30 times 7 is 210. So our final answer is 539 minus 210 root 6. And to finish up, we have a nice and easy one in question 4, simply going to be using the third formula here. So we have our root 7, which is our first thing, minus the root 3 squared. This is just difference of squares. So root 7 squared is just 7, and root 3 squared is just 3. And 7 minus 3 is equal to 4. So our final answer for question 4 is 4. So now we come to a harder example. The question says, without expanding, simplify the expression root 7 plus root 2 all squared minus root 7 minus root 2 all squared. Now, because it says without expanding, it means we can't just do each one separately and expand them out. So typically what we could have done is say, okay, well, this is just root 7 squared plus root 2 squared plus 2 times root 7 times root 2, and then do something similar for the second one. But because it says without expanding, we can't do that. Rather, if you look at this, what is this? This is a square. It's something squared minus another thing squared. So you can think of this as x squared minus y squared. Now remember, we can work both ways, right? So whenever you see a squared minus a squared, we can factorize it and say it's x minus y times x plus y. So in this case, x is equal to root 7 plus root 2, and y is equal to root 7 minus root 2. So let's see if we can use the factorization to simplify this expression. So we have our x minus y first. So it will be root 7 plus root 2. So that's our x minus our y. So our y is root 7 minus root 2. And that is basically this bracket here. And then our second bracket is x plus y. So it'll be root 7 plus root 2 plus root 7 minus root 2. So now if we expand and simplify this, we can see root 7 plus root 2 minus root 7. So these cancel out. And then root 2 minus root 2 is the same as root 2 plus root 2, which gives us 2 root 2. So this bracket is equal to 2 root 2. And then this second bracket, you can see the root 7 plus root 7 gives us 2 root 7. And root 2 minus root 2, well, they cancel out. So we're going to be left with 2 root 7 in this second bracket. So 2 times 2 gives us 4. And then root 2 times root 7 gives us root 14. And we can't simplify this further. So our final answer would be 4 root 14. So now we have 2 more harder examples. So by combining the fractions, simplify the following. So pause the video and have a go, and then unpause so that we can go through the solution. So for question 1, we're just going to be adding fractions as we normally do. And remember, that means finding a common denominator, or alternatively, using the crisscross rule. Now, if you aren't familiar with the crisscross rule, it basically, I'll use it for a simple example here. So let's say we're doing 3/4 plus 1/5, for example. if we're going to be doing that, we can use crisscross. So the first criss is this way, and the second criss is that way, and then we have the cross. I don't know if that's actually a criss or a cross, but let's just do it like that. So we have 5 times 3, so that's going to be 15. Then we have a plus 4 times 1, which is 4. And then our denominator is going to be 4 times 5. So each arrow just represents a multiplication. So 4 times 5 is 20, and that is equal to, well, 19 over 20, and that gives us our answer. So hopefully you can see that's how the crisscross rule works. So let's apply that for question 1. So here, if we're going to crisscross, we're going to be crossing the root 2 with the 1, the root 5 with the 1, and then the root 2 with the root 5. So we're going to be getting root 2 times 1, which is root 2, plus root 5 times 1, which is root 5, and then over root 5 times root 2, which is equal to root 10. Now, we can't actually simplify this anymore. We can technically rationalize the denominator, but for now, we're going to keep it like this, and we'll cover that in the next video in our Surds series. So for question 2, we're going to be doing the exact same thing, right? So crisscross rule. So we want to do the 1 times root 2 minus root 3. Now, 1 times anything is just itself, so we just get root 2 minus root 3. Then plus, this is the next cross, so we have 1 times root 3 plus root 2. So that's going to be root 2 plus root 3 over. Now, when we cross these two together, this is where the bit of theory we learned today comes in. What is this? This is something plus something. In fact, let's just write it out full form first, and then we can break it down. So we have root 2 plus root 3 times root 2 minus root 3. Now, on the top, we have root 2 plus root 2, which is 2 root 2, minus root 3 plus root 3. They cancel out, so it just left like that. Now here we have a difference of squares, right? We have something plus something times something minus something. So it's going to be the first thing squared minus the second thing squared. So we have 2 root 2 on top over square of root 2 is 2, square of root 3 is 3. So we have 2 root 2 over negative 1, and that is simply equal to minus 2 root 2. And that would be our final answer for question 2. So hopefully you've learned the crisscross rule in this video, and you've also learned how to use the difference of squares, which is actually very important for next video where we talk about rationalizing the denominator. And finally, the last example for this video, an equilateral triangle has sides of length 2 plus 2 root 3. Question 1, find its perimeter, and question 2, find its area. So pause the video and have a go, and then let's go through it. So question 1's pretty simple, but first I think it's a good idea to draw a diagram of what this triangle even looks like. So it is an equilateral triangle. So it would look something like this. Now, side lengths of 2 plus 2 root 3. So this has a side of 2 plus 2 root 3. This has a side of 2 plus 2 root 3. And so does this 2 plus 2 root 3. Now we know they're all the same sides. So the perimeter, very simple, right? We just add up all the sides. So it's basically 3 times 2 plus 2 root 3. And if we get the answer, it's just 3 times 2, which is 6. 3 times 2 again, which is 6 root 3. And that would be our answer. We don't know what type of units it is, so we're just going to say units. Now for question 2, find its area. So this is actually a bit more challenging, right? To find the area of a triangle, remember we need half base times height. Now we know what half is. The base we can say is this here, but what do we need? We need the perpendicular height. And to find the perpendicular height, we need to draw a perpendicular straight down from the other vertex and figure out what this is. Now, to figure out this, hopefully you can see we have to use Pythagoras. We know the hypotenuse. We're trying to find h. Do we know what this side is? Well, if we know that the entire side is 2 plus 2 root 3, and this is an equilateral triangle, then it's pretty safe to assume that this side here, in fact, I'll just put it in green here, is going to be half of 2 plus 2 root 3, which means it's going to be 1 plus root 3. Okay, because a half of 2 plus 2 root 3 is just halving everything. Half of 2 is 1. Half of 2 root 3 is root 3. So now let's figure out what h is. It might be a good idea to draw out this triangle somewhere else. I'm just going to draw it over here. So we have 2 plus 2 root 3 as a hypotenuse. We have h here, and we have 1 plus root 3. So as always, let's write down the Pythagorean statement and then solve for h. Or alternatively, we can go straight to solving for h. In fact, let's just go straight to solving for h. So h is equal to the square root of our hypotenuse squared, so 2 plus 2 root 3 all squared, minus our other short side squared, which is going to be 1 plus root 3 all squared. So let's put into practice what we learnt today. So 2 plus 2 root 3 squared, all squared, just means square the first thing, so 4, plus square the second thing, so 4 times 3, which is 12. Then plus 2 times the first thing times the second thing. So 2 times 2 is 4, and then times by 2 root 3 is going to give us 8 root 3. And then minus, now we do the same thing. So square the first thing, which is 1, square the second thing, which is 3, and then plus 2 times the first thing times the second thing, which is going to be 2 times 1 times root 3, which is 2 root 3. And I'm running out of space here, so I'll just bring it over here. 4 plus 12 is 16, so we get 16 plus 8 root 3, so I'll just write that there. And then we have minus 1 plus 3 is 4, so minus 4. And then we have minus 2 root 3. So to get our final answer for the height, this is just the height, remember? 16 minus 4 is 12. And we have 8 root 3 minus 2 root 3, which is 6 root 3. So we have 6 root 3. So it's the square root of 12 plus 6 root 3. So now we can find the area quite comfortably. So let's change back to black here. So half times our base. Now our base is 2 plus 2 root 3. And then our height is equal to the square root of 12 plus 6 root 3. So the answer, if you just put that into your calculator, is going to be equal to approximately 12.928. So about, in fact, if we just round that up, about 13 units squared, okay? So that's our final answer for question 2, and hopefully you can see how it was able to use the theory we learned in the previous parts of this video and use it in a bit more creative way. So that's the end of this video. In our next video, we'll be talking about rationalizing the denominator, and that will be the final theory video in the Surds series for year 9. So catch you there.